Okay, this is for the Section 8 study guide. I'm going to go through just some notes kind of for each one, and then I want you to try it on your own, so I will just flash to the answers once I get particular parts. This is the music playing for interchange of classes. Okay, so find the value of each trigonometric ratio. So the trig ratio, you should have notes on this, so make sure you reference your notes, but I will put up at the top the acronym that we use to help us instead of having all the words out. But really, every single time there's an equation for sine, there should be an angle after it, so some angle with the degree, and then whatever falls on the opposite side over whatever's on the hypotenuse. So this is the equation that you use every single time sine is involved. Cosine, same thing, with the angle, reference angle. The A stands for adjacent, H is for hypotenuse, that's in your notes. And tangent, same thing. So please reference your notes for what these things stand for: opposite sides, hypotenuse, and adjacent side. So what you want to look for is for the first one, you're looking at tan, the tangent, which is opposite over adjacent, and the A is our reference angle. So in this case, Z is our reference angle. So we want to identify that so that way we have the correct opposite and adjacent sides. Because if we go from a different reference angle, our opposite side changes. So it matters which reference angle you pick, so that which side is opposite matters. So this is determining that this side is O, which is opposite, and this side is A because it's next to the angle and in between the 90 and the angle. So tangent would be, and then the equation is already half written for you. They already wrote this part of the equation. So we're just writing the equals. Well, actually the equals is there. We're just writing what's on the opposite side over what's on the adjacent side. So we're writing 21 over 28. Okay. 21 over 28 can be simplified. So we would do that by dividing each of these by 7. So 21 is divisible by 7 and it gives us 3. 28 is divisible by 7 and it gives us 4. So 3/4 would be our simplified version of the answer. Okay, so go ahead and try the rest of these. Pause the video if you need to, and then check your work. Again, you're looking at the equations to tell which sides to do. Excuse me. Both divisible by 7? This time my reference angle is Z, so I'm changing. Now this is the opposite, and this is the adjacent. So notice on every single other one of these, opposite side was over here. Now the opposite side is way over here.
Please lock your doors at the last bell. Please lock your doors at the last bell. Students, if you're in the hall, when that last bell rings, please head to the cafeteria. You are called.
Okay, so adjacent and hypotenuse, so it would be these are both divisible by 8. Okay, so that's the answers for the first part. The second part is very similar. We're still using trig ratios. So we're still going to be writing one of these 3 equations every single time. So from this angle, I'm just picking one. This side would be opposite, this side adjacent. So I'm using tan because that's the equation that involves opposite and adjacent. I don't know my angle, so I call it unknown, which x stands for. It's just my unknown angle. Opposite over adjacent. Okay, these to plug them into your calculator. Whenever you're finding an angle, you use the inverse trig. So you're using the negative ones here. So if I invert this, I can get x. Okay, so 27 divided by 38, that gives me that number. And then I'm going to hit second tan. So it's about 35 degrees to the nearest degree, which means the nearest whole number. so 35 degrees. One more time with a different calculator. If you have the kind where you can type it in like you see it, you just hit second tan, 27/38. And again, same thing, 35 degrees to the nearest hold. So go ahead and pause it, try it, check your answers for these. I'm just going to roll through these real quick. So the first three are all tan. So 26 degrees. The last one's not. So sine, which is opposite over hypotenuse. Again, pause it if you need to. Check out what the sine is. It's the opposite, whatever's on the O side, over the hypotenuse, whatever's on the hypotenuse. And you're still doing the inverse to get the angle. Ten divided by 39 equals second sine. Do that one more time. 10 divided by 39 equals second sine, so you can see it. Okay, next section. Part 3, finding the missing sides. So again, Moultrie. So this whole front side pretty much involves trigonometry. So from my reference angle, I'm still labeling my sides. So it's very important that you know how to label the sides, O, H, and A. That's the setup foundation for all of these problems. To solve this, I would get, I could solve this a couple different ways. I could divide this by 1 and cross multiply. Or I could just solve it like a regular algebra problem and get x by itself by multiplying by the reciprocal. Sorry, but multiplying both sides by x, which cancels it on this side. So I have x cosine 72 degrees equals 6. And then dividing both sides by cosine 72. And then that's what I would type in my calculator. So pause, rewind, slow down, whatever you need. I know I go through this pretty quickly. But we did a lot of practice on this in class, so hopefully it's becoming more and more familiar. 19.4 is to the nearest 10th. So make sure you're rounding to whatever they say, or else the answer is incorrect. So if you put 19.3 here, 19.5, or 19.42, or 41, it's incorrect. Okay, then pause it, try these other ones, see if you got the right answers. Notice sometimes x is on the top, sometimes the number's on the top. It matters in when you're using the equations. For tangent, the opposite, whatever's on the opposite side always needs to be on the top. Whatever's on the cosine, for cosine, whatever's on the adjacent side always needs to be on the top. It is a good idea to show all this work, because otherwise when you're trying to go back and look at what you did, if you don't have any tan, sine, cos, if you don't have any of that part written, then it's very difficult to follow your work and try to practice when you're doing this for the test. 12.2. Okay, last section on this. Find the side length x. So x right now is on a right triangle with no other sides known, just one angle. In order to do special right triangles, we need to know at least one more side. And trig, same thing. So we can't start with this triangle. We have to start with this right triangle on the left. We can find this length, which I'll call y. I won't call it x because x has a specified value for this problem, so I don't want to label it x. That's misleading. These two sides cannot be the same on a right triangle. The hypotenuse is always the longest side. It's not equal to any other side on the right triangle. So if I use this triangle and find y, then once I have y, I can use this triangle and find x. So to do that, I'm going to start with the 39 degrees as my reference. Label my sides. This is across from the 39, so this would be O side. This is my A. So I'd be using tangents equation, which is opposite whatever falls on the O side. Doesn't matter if it's a number or a variable. And solving for y. Okay, I'm going to leave that whole number in my calculator, even though I'm going to round it on my paper to the nearest thousandth. I want to leave it in there so my answer is exact. If you're not at the very end of your problem, it's best to leave that answer in your calculator so you get an exact answer when you're solving. So now going from the 60-degree angle, this is still the O side, which is nice. Didn't change. But now we're using O and H, which is going to be the trig function for sine. Y, which was that whole number. And when I solve for x, to get x by itself, I have x sine 60 degrees equals 30.772 with some numbers behind it. So in my calculator, I'm going to type in that number, I already have it, and then just hit divided by sine 60. $35.5. Okay, here I want to stop and check to see if this is a reasonable answer. Is it reasonable that across from a 39-degree angle is a side that's a little bit smaller than across from a 38-degree angle? So this angle, if I was to solve it by using my triangle angle sum, would be 51 degrees. So it's a bigger angle across from a bigger side. That makes sense. So this side should be smaller than 38. Then on this triangle, this is not the hypotenuse, so it should not be the longest side. This x should be longer, and it is longer. So this is a reasonable answer. Okay, 8. Again, I need to start with the left triangle because I have a side known on that left triangle, and I don't have a side known on the right triangle. I'm going to call it y since there's already an x. You can solve the algebra out each time. I'm going to start skipping that step because you should be able to solve the algebra because it's pretty consistent. But you can do that process every single time if you need to. The work that I need to see for this is just what you set up and solved for y. 12.853. 35 is a smaller angle than this, so 12 should be a bigger side than this. That's good. Good, reasonable answer. On the second triangle, this angle is my A still. That's nice. And this is my O, so it's still tangent, but it's a different reference angle. So notice the reference angle is changing because we used a different triangle. Same on this one, the reference angle is changing. Opposite would be x. Y, which is what we just found, is the adjacent side. Multiply both sides by 12.853. I already had that in my calculator, so I just hit times tan 61. And I get 23.2. That's the value for x. It's across from a bigger angle than y's was, because this will be a 29-degree angle. So this should be a smaller side, but this should be bigger, so that's correct. That's reasonable at least. Okay. Okay, then we get to part 5. Label the triangle sides so that sine x is equal to m. So remember, sine from an angle is equal to the opposite over the hypotenuse. If it's equal to m as well, that means m over 1. So that means the opposite side is m, opposite of x is m, and the hypotenuse is 1. Okay, and cosine from x, so cosine from that same angle, which is adjacent of hypotenuse, is just p, which means p over 1. I'll draw my ones like this so it doesn't look like an L. Okay, so the adjacent side is p, the adjacent side is p, and the hypotenuse is 1. So when they give you a sine and a cosine with a value and it doesn't have a fraction underneath it, it just means it was over 1. It just got simplified. So it's still in the form O over H or A over H, but these are 1s, and we don't write 1s when we divide. So that's why it just you just see an M and a P. Ugh. Okay, so that's all we did so far as part A. Part B is now we want to find the sine from Y. So we have our sides labeled. So from Y, the opposite side now, if we do make this our reference, opposite side would be P over the hypotenuse is still 1, which just equals P. And then the cosine from Y would be the adjacent side, which would be M, over the hypotenuse, which is 1, which is just simplifies to M. So notice that the sine from X is equal to the cosine from Y, and the cosine from X is equal to the sine from Y. That's because the sides change. So from X, this is opposite, but from Y, this is opposite. So the adjacent side is the opposite side for the other one. So that's why the cosine and the sine of the opposite angles match. If we wanted to do tangent from X now, so switching back from X, tangent would be opposite, so M over adjacent P. And that's our ratio for that last side. So this is really just conceptual to see if you understand how to label the sides really, really in-depthly, and even how to simplify it and get back to the ratios that were existing before you simplify it. So pause that, replay it if you were confused on something. Go back through it. Number 6, right triangle similarities. So it gives you a hint, but on the test it doesn't tell you which problems go with which topics. So you need to be able to recognize. On this problem, you cannot do trig. You don't have an angle, and you're missing a side. On this problem, same thing. So whenever you have, really when you have the two right triangles drawn in within each other, two right triangles drawn within a big one, then that should key you to geometric mean. So this is a geometric mean problem. And we can use the altitude rule because x is an altitude. So the altitude rule, if you go back to your geometric mean notes, says that the altitude is equal to the square root of the hypotenuse segments. So in this case, the altitude is x. It's equal to the geometric mean between hypotenuse segments 1 and 2. Doesn't matter which one's 1, which one's 2. 4 is a perfect square, so this will become 2 radical 11. Or, if I type it in my calculator and get a decimal answer, it's also equivalent to 6.6. So either of those could be the answer that they put on the test. So it can be in either form. You've got to know how to get both forms. B, we can do the leg rule, or we can do the altitude rule, whichever we prefer. We're looking for x, which is part of the altitude rule, so we can use x to do that. So for the altitude rule, I already wrote it, so I'm not going to rewrite it, but I will write the answer. So the altitude, in this case, identify which one is the altitude. It's going to be the part that's in the middle of your figure, so it's 4.6 is equal to the geometric mean between hypotenuse segments. The hypotenuse is the longest side of the right triangle, so it's this side is the hypotenuse. So hypotenuse segment 1 would be 11, and hypotenuse segment 2 would be x. Okay, to solve this, we square both sides. That gets rid of the radical. So we just have 11x, because these parts cancel. 4.6 squared, 21.16. Divide by 11. 1.92. Find CD. It's an altitude, so we can use the altitude rule. Altitude equals the hypotenuse segments multiplied together. 4 is a perfect square, so I can get 2 radical 3. Or, if I type in the square root of 12 in my calculator, it gives me 3.46. Or, if I type in 2 times the square root of 3 in my calculator, it gives me 3.46, which is about 3.5. This is actually exact, this is approximate, but either of those answers might be what you see on the test. Okay, the altitude of a hypotenuse to the hypotenuse of a right triangle. I'm just going to sketch it. It's always a good idea to sketch if there's no picture. The altitude of the hypotenuse of a right triangle divides the hypotenuse into segments whose lengths are 12 and 48. What is the length of the altitude to the nearest tenth? So they specify this time what they wanted in. So we're not going to do the square root answer, we're just going to get it to the nearest tenth. But we apply our altitude rule one more time. Actually, it comes out to, oops, sorry. So it's going to be 24. 24.0 to the nearest tenth is still 24. Okay, part 2, that's all the trig and geometric mean. Really no special right triangles yet or Pythagorean theorem, but those two things are covered on your test. So part 2 has a little bit more of everything. So what are the ratios for sine, cosine, and tangent for L and M in simplest radical form? So we'll write each of those out just for, well, for both. Okay, so from M, I make this my reference. My opposite side is across from that, so it's 2 radical 3. Over my hypotenuse for this whole problem is 4, doesn't change. Simplest radical form, I want to reduce, I don't want to put the decimal in, I just want to reduce the whole number, the numbers outside the radical, so the 2/4 becomes 1/2, which I don't need to write the 1, because 1 times radical 3 is just radical 3, so that's my answer. Cosine is adjacent over hypotenuse, so that's just going to be 1/2. Tangent is opposite over adjacent. 2 divided by 2 is just 1. 1 times radical 3 is just radical 3. So anytime you have the same number on the denominator, you just don't need to write it. Okay, we would expect that for L, these two would repeat, but in different orders. So I would expect that L's would be 1/2. But let me just check. Opposite of L and hypotenuse is 2/4, and it is 1/2. Cosine would be the same cosine that we got here, which reduces to radical 3/2. Tangent will be different. 2 is the opposite side from L, so that's opposite, over adjacent, which is the 2 radical 3. Okay, so we get 1 over 1 radical 3. We do need to write the 1 on the numerator this time because we need a placeholder. Radical 3 is not, simplest radical form does not allow radicals in the denominator, so we have to rationalize this. So 1 times radical 3, if we multiply the numerator, it becomes radical 3. 1 radical 3 times radical 3 is 1 times radical 9, which is a perfect square of 3. Part 2 are the following are sides of a triangle classified each by their angles. So we want to classify them as acute, right, obtuse, or equal angular, but none of these are equal angular because they don't have three of the same numbers. So when they say classified by angles, it's talking about one of these 3 classifications. So just to remind you, acute angles, a squared plus b squared is greater than c squared. Obtuse, a squared plus b squared is less than c squared. So just kind of think of it as like c is so large on the obtuse ones that it's greater than these combined. The greater opening is pointing to that. On the acute, we know all equilateral triangles are acute, so if you just think of like 2, 2, and 2, if these were all the same, it would be an acute triangle. All the angles would be 60, so they're all less than 90. And you would think of which way does your symbol need to go if they're all the same. So if they're all the same, 2 of them added together should be greater than the last one, so the acute one is the one that has the greater than sign, and the obtuse has the less than sign. Although usually acute is less than 90, it's greater than C. Okay, and then right, of course, is the equal. It's the Pythagorean theorem. So you want to do is identify C. You don't care so much about A and B because they're going to be added together anyways, so B could be A or A could be B, but C is important to identify. So I'm just going to identify which side is C in each of these problems, and it may not be written first. Okay, C is the largest side, but it could be, they could have switched it up and written it in a different order. So C is 7. 7 radical 3, if you weren't sure, you would type it in, but I know 14 is bigger than that because 7 radical 3 turns out to 12. So the side that's largest is last, 14. The largest number here is 34, so C is 34 on this one. And then for fractions, if you don't know them, you just divide it. So the first fraction, 0.2. 0.28. Oops. 0.3. So they put these in order, which is nice. I already know the square root of 2 is 1 point something, so I know this 2.25 is the biggest. So the square root of 2 is 1.14, so this is still C. And 1.2 is C. Okay. So if I square 4 and 3, I get 16 plus 9 and 49. I already know that's not going to reach 49. So 49 is greater, which makes this triangle obtuse. These sides actually cannot even make a triangle, but that's not what this is so much testing. But remember, the 2 sides added together have to be greater than the last side. They can't be equal, so these actually would not even, this would not even make a triangle. Okay, but that's kind of not what this is. I just made these numbers up and didn't even realize that I made one that was not going to make a triangle, but obtuse if you were to do the formula. So second one, if you do 7 radical 3 squared. Okay, so let me just show you. If you take the square root of 3 and you square it, it comes out of the radical, so it's just a 3. 7 squared is 49, so we're just doing 49 times 3, which is 147, plus 49, which is 196. It's equal to 14 squared. So 196 is equal to 196, so this one's a right triangle. Okay, 16 squared plus 30 squared is 1156. 34 squared is also 1156. We got them to be equal again, so it's a right triangle again. Okay, fractions, you can type them in just like you see it. 1 divided by 5 squared plus 2 divided by 7 squared. Oh, man. Okay, I'm messing up. 1 divided by 5 squared, just so you can see it. Plus, and I'm not even clearing anything. I'm not hitting enter or anything like that. 2 divided by 7 squared. That tells me that the a and b squared together is 0.122. Then if I just do 5 divided, oops, I want to put it in parentheses so that it squares not just the 13, but both of them. It's 0.14. So this is still bigger, so it's still obtuse. So let me do it on different calculators so you know that in case you can't type them all in where you see them all together, you can still do it. 0.5 squared plus the square root of 2, 2 square rooted squared, which is a regular 2, it'll just come out, equals, those added together is 2.25. And then if I square 2.25, I get 5 point something, which is bigger, so a lot of obtuse. So this one was tricky because if you didn't square C, it looked like it was equal to A and B. But remember, you got to square all of them. So again, we squared the 5.5 and added it to the square root of 2 squared is 2, so we added it to 2. But we had not yet squared this side, so when we square this side, it's now bigger than these two added together squared. So 5.06. Okay, last one. 0.4 squared plus 0.7 squared equals 0.65. Okay, so we didn't do any acute examples. 1.4. But that's okay. So at least you know, if you know how to find it, you can still tell whether they're cute. Okay, moving along to number 3, given the sign of, okay, and they gave us something funky here. So this is one little thing in our notes we put underneath the trig part just because they had one question on the test that was randomly this, which really has nothing to do with trig to find it. But these angles, the sine from one angle in a triangle, so remember the sine from like A, for instance, is equal to the cosine from B. So if something's sine is equal to something else's cosine, these angles, they're A and B, which are complementary. So A, this is essentially A and B, which add to 90 because they're the two other angles inside of a right triangle. And remember, all three angles in the right triangle equal 90. So what you're going to have to do is plug in, and it's just this part that's A, and just this part, not the cosine words or sine. So 3m minus 15 is A, plus 7m plus 5 is B, equals 90. And now it's just algebra. Coming over here because I'm out of space. And m is 10. Okay, one random problem that are complementary. So just remember these are complementary. Okay, length of the long leg of a 30, 60, 90. So back to the 30, 60, 90 is just a good review. Doesn't matter where you put the 30, 60, 30 and the 60. As long as you make the side across from the long leg means the 60. Because these are the two legs. This is the hypotenuse. So this would be the short leg, long leg, hypotenuse side. So the long leg, they're telling us across from the 60 is 14. Find the perimeter. You could use trig for a question like this because you know a side and an angle. And you can ignore 30, so you can pick 60 as your reference angle. The special right triangles is a lot faster, so I'm going to use that. The shortcut for knowing the 60 side, so remember if we know the 60 side, we times by radical 3 and divide by a regular 3, and that gets us the short leg. That says 14 radical 3 over 3. And then this is just double the short leg. So whatever this is, remember this is a 1 ratio, this is 2. So our scale factor is essentially this. We multiply it by 2. Again, if this is confusing, you can use trig. Okay, for that, after that, you're going to find the perimeter, so you have to add all three of these sides up. So it's a lot of mess. 14 radical 3 over 3 equals. Okay, and I'm going to times this by 3. And the reason I'm going to do that is because this is one of those. This is 2 more of those. So timesing it by 3 accounts for all 3 of them. That and that. And then the 14. So it's about 38.2. Okay, if I did it all out on the little calculator so you can see that 14 times 3 radical divided by 3 equals that. Plus 14 plus, and then I'm going to put in parentheses so that my whatever operations doesn't mess me up. So 28 times 3 radical divided by 3 in the parentheses, and then hit equals. So I still did the same thing. In the center of town, there's a square park, so always draw a picture. It's helpful for these kind of problems. With a side length of 16. Well, if it's a square park, all of the sides are the same. If Michelle, that's my sister's name, walks from one corner of the park to the opposite corner, how far does she walk? Well, it's a square, so the 90-degree angle just got cut in half, making it a 45, 45, 90, so this is actually a pretty quick problem if we use special right triangles. If you don't like special right triangles, you can use Pythagorean theorem for this, trig, or special right triangles. Because you know 2 sides of a right triangle. So you're essentially ignoring the fact that it's a square now. You're looking at the fact that it's a right triangle with 2 sides known, so you can get Pythagorean theorem to find that last side, or special right triangles, or a trig. And we're looking for this side as x. So 16s are my 45s. Across from my 45 is 16. Across from the other 45 is 16. So this is 16 radical 2. Which as a decimal to the nearest foot would be 23 feet. So nearest foot means nearest whole number. All right, number 6, solve for x and round to the nearest tenth. So we want to make sure we're rounding to whatever they ask us to round to. Okay, my first thought when I see a triangle within a triangle is a geometric mean problem. If I tried to do the altitude rule, x isn't on the altitude, so I don't really need that part. And even if I was trying to find this, I don't know either one of the pieces I need for the altitude rule. If I try to do the leg rule, I have a leg, but I don't have either one of the other segments I need to find the leg rule. So although this has a triangle within a triangle, I will not use a geometric mean. So what I want to look at is on the right triangle, if I make this a right triangle, I know it's a right triangle because this is 90, if this is 90, so these two have to be supplementary. This is already 60, so this is 30. And this was already 60 and 30, and 60 make a 90-degree angle. So what I really have is a disguised triangle, 30, 60, 90 triangle. 30, 60, 90, across from the I'm giving the side across from the 60, so I'm giving this as 5. So I use my shortcut to find across from the 30, which would be x. So 5 radical 3 over 3. That is my answer, but I need it to the nearest tenth, so I have to plug it into my calculator. If you're doing it on this time, you just got to make sure you're closing parentheses. So close parentheses after you do the square root, divided by 3, so it's 2.9. To the nearest tenth, which is reasonable. It should be smaller than this side because it's across from a 30-degree angle. Okay, you can do this other ways. You can do the trig here, but special right triangles does save you a lot of time if you understand how to do it. Okay, a 30-foot ladder is propped up against a vertical wall, so we have a vertical wall. And that's my vertical wall. My ladder is propped up against it, so figures help. And it makes a 32-degree, and the ladder is making a 32-degree angle with the ground. How high up is the ladder from the wall? So that's my picture. That's a 32. So we're doing, for this problem, it's a 32 degrees, so I can't use my special rights. I don't have 2 sides, so I can't use Pythagorean theorem, and I don't have a triangle within a triangle, so I won't use geometric mean. So I'll be doing trig. So for my reference angle, the x is my opposite side. The 30 is a hypotenuse, so I'm using sine. Sine is always opposite on the numerator, hypotenuse on the denominator. So that's my equation. Then I want to solve this for x, so I multiply both sides by 30. So to the nearest tenth is 15.9. Is it reasonable? Yes, it's less than 30. It's within the range of side lengths if you have a 32-degree angle and a 60-something degree, well, 58-degree angle. Okay, find W and X. So on this problem you have a right triangle. If we ignore this, we can do trig to find W pretty quickly. And then if we ignore this, we can find what W plus X is. But we can't find X on its own because it's not a part of a right triangle. So unfortunately, we can't get just X. But we can get just W. Or W plus X, which is what this length would be if you combine those. So to find X, which is what we're going to have to find on the test, you're going to have to do both of these trig functions and then subtract to figure out what X is. So if we do the trig function for this one, we have opposite and adjacent sides, so tangent 56 equals the opposite over the adjacent. So this would be a problem where I divide. And get 6.745. This is actually still the same trig equation, so it's still tangent, but it's 34 now, so our reference angle is different, and it's 10 and it's W plus X now. So W plus X is equal to 10 over tan 34. So W plus X is 14.826 minus the 6.745 that we got before. That means X, so W, that's one answer, and then X would be 8.081. So this one problem, and one of the tests is like this. You have to just do trigonometry twice. Once you do it the second time, that gives you the whole length all the way from the 90-degree angle to the 34-degree angle vertex. But you have to subtract out W because they just want X is just from this. X is just from here to here. Number 9, you're standing at point D in the diagram looking at up to point A. Triangle ADC is a right triangle. And AC is perpendicular, which means these are right triangles to BD. B is 65 yards from A and 80 yards from C. So they're still talking about point B here. So B is from this much from A and this much from C. So from B to C is 80, not from A to C. So this is a tricky part for reading comprehension. What is the distance to your position? What is the distance your position to point A? So we were standing at D. We want to know this length. So on the geometric mean problems, this is a leg because it's one of the sides of the right triangle. That's not across from it, so it's a leg rule problem. Or you can use proportions. So the leg rule says that the leg is equal to the hypotenuse segment closest to the leg times the whole hypotenuse. Okay, so the leg that we're looking for in this case is x. The hypotenuse segment out of these two closest to the leg is 65. And then the whole hypotenuse is, if I add these together, I get 145. So it's about 97.1 yards. We're almost done, 2 more. So Marcia wants to walk from the parking lot through the forest to the clearing. From the parking lot through the forest to the clearing, as shown in the diagram. She knows that the forest ranger station is 54 feet from the flagpole, and the flagpole is 25 feet from the clearing. So clearly not to draw into scale. That's okay though, we're going to basically be using, since we're looking for how far is the parking lot from the clearing, a leg, we're going to be doing the leg rule again. So the leg rule, we already wrote it up here. It's equal to, the leg is equal to the square root of the part of the hypotenuse closest to the leg, which would be the 25 is the closer segment, times the whole thing. If I add these together, I get 79. I can make this 5 radical 79 because I know 25 is a perfect square, but if I just do the square root of 29 times 5, it's about 44.4. And I can check it. It's 44.4. So that's the nearest tenth, or in simplified radical form. Okay, last one to prep for your test. You can also please prep using Math Excel. You should have done all 5 assignments for section 8. And you can review the Mathination handouts. Which is the classwork. I don't know if I've given most of those back, but the answer keys for the last ones for the geometric mean at least are online. Okay, the last one, segment EC, is 6 units long, so this segment's 6 units long. Find the side length of DC and the measure of angle ADC. So we're looking for this degree and this side length. They don't give us any angles or anything else. Actually, the picture gives us some stuff. So the picture means these all are the same, and these are all the same. So since there's a triangle and they're all 3 the same, it means it's an equal angular triangle. So we take the angle sum, which is 180, and we divide that by 3. So each angle is 60 degrees. And these were marked with the same markings, so x is actually 60 degrees. If I redraw, okay, you can pause it and redraw the triangle and play it. So 6 is EC. We want to figure out what the hypotenuse of this 30, 60, 90 degree triangle would be, because this is a 30 degree angle. Okay, so we have the 6 is across from the 30, so it's the short leg. And we're looking for the side across from the 90, so we're looking for the hypotenuse, which is just double that since our scale factor is 6. So this would be 12, and that's our other answer. Okay, so that's the angle for ADC for Y, and that's the measure of, this is the angle for ADC, and this is the measure of DC. Okay, I'll be here well, your test is this week, so make sure you come in for tutoring on Thursday if you need help.